Hi class, this is Course 3, Lesson 61 on sequences. Okay, a sequence is an ordered list of numbers called terms that follow a pattern or a rule. We have two types of sequences. An arithmetic sequence looks like this: 1, 4, 7, 10, 13, and so on. There will be a constant difference between the terms. So if I take one of the terms and I subtract the previous term, I get a value, in this case 3. If I take another one of the terms, let's say 7, and subtract the one previous to it, I get the same value. So there is a constant difference between the terms. In a geometric sequence, it looks like this: 1, 3, 9, 27, and so on. There is a constant ratio between the terms. So if I take one of the values, one of the terms, and divide it by the previous term, I get a value. If I take another term and divide it by the previous term, I should get the same value. Okay, so in an arithmetic sequence, there's a constant difference between terms, and in a geometric sequence, there's a constant ratio between the terms. So you will be asked to describe the pattern and find the next three terms in a lot of the problems. So in this arithmetic sequence, you would say that you would add 3 to find the next term. Okay, so, right, 1 plus 3 is 4, 4 plus 3 is 7. That's that constant difference that we're going to add to each term. So the next three terms would be 13 plus 3 would be 16, then 19, then 22. 16 plus 3 is 19, 19 plus 3 is 22. In the geometric sequence, we're not adding anymore. Hopefully you can see, because we did some division here, we're really multiplying each of these terms by 3 to get the next term. So we would write multiply by 3 to find the next term. So the next three terms would be 27 times 3, which is 81, 81 times 3, which is 243, and 243 times 3, which would be 9, 2, 729. Okay, so there's a lot of information here. Biggest difference is that arithmetic sequence, you have a difference between terms, and geometric, you have a ratio. So now the terms of a sequence have a position and a value. So the number of the term, that's n. Okay, so we're going to use the variable n for the number of the term. So this is the first term, the second term, the third, the fourth, and the fifth. And this would continue forever. And the value of the term, that'll be a. And this is the list that you would see: 3, 6, 9, 12, 15, and so on. In an arithmetic sequence, it'll look like this: n, a. The number of the term is 1, 2, 3, 4. The value of the term, 3, 6, 9, 12. The constant difference here being 12 minus 9 is 3, 9 minus 6 is 3, 6 minus 3 is 3. Okay, and you can graph those points as the number and the value. Like this is your x and this is your y. So the position number is 1, and your value for the term is 3. Your position number is 2, and the value for the term is 6. Okay? Geometric sequence, same values for n. It's going to be the first term, the second term, the third term, and the fourth term. In this case, we have the values of the term as 1, 3, 9, and 27. So if we graph those, again, treating n as your x values. 1, 1, 2, 3, 3, 9. Notice that in an arithmetic sequence, we can draw a straight line through those points, and they're all aligned. We could use that line to determine the next value. A geometric sequence is not a straight line. It's actually a curve. I hope you can see that without me drawing on there. It would go like this. You see how it goes up steep, sharply curves up, and this one would start at 0, 0 and would go like this and would just make a straight line. Okay? Arithmetic sequences are aligned and geometric sequences are not aligned. So if you're not sure if it's arithmetic or geometric, you can graph the sequence number with the value and determine which type of sequence you have. Okay, so if we're writing rules for sequences, we can write rules using formulas or words. So here's a sequence, 3, 6, 9, 12, etc. And first you're going to make a table. We're going to have number represented by variable n and the value represented by variable a. And we're going to put in the number. Now your number, this is the term number, so it should be 1, 2, 3, 4, because this is the first term, this is the second term, etc. The value, those are the ones that are listed, 3, 6, 9, 12. So if we were to write this formula, or this rule for the sequence out in words, let's do words first. We can see that if you have your number, we take the number, the position number times 3, the position number times 3, the position number times 3, position number times 3. And this is the same type of sequence that we just did, where it would, you would say you would add 3 to each term, but that's not what you want to write down here. And I know that that might be confusing, but this should be, you would multiply the term number by 3. Okay, that will get you the value to get the value. Okay, so how is that represented as a formula? Well, I'm going to show you something a little different here. This tells you, notice, okay, it says a n equals 3n, right? This is a sub n, so it's a sub n. That's how you would read it, equals 3 times n, or 3n. This n is a subscript. You don't multiply it. It's just telling you which value for a that you have. Okay, so we can use this. We're going to use the formula to find the 10th term. Okay, so the 10th term would be saying n equals 10. So we're going to substitute 10 in for both of these n's, and we're going to go the value of the term n. We're going to place a 10 there. A sub 10. The value of the 10th term equals 3 times 10. So a sub 10 equals 30. Now, what I know by looking at this is that the 10th term is 30. That's what that subscript 10 means. That's all you need to do. There's nothing on the A side with that subscript. That's just a notation. It's the 10th A value. Okay, so that's a little new for you, but Hopefully I did a nice enough job for you to understand, and if you have questions about that, you'll ask them in class. Now here's a geometric sequence. We're going to do a rule for the sequence using formulas and words. So 1, 3, 9, 27, it's the same geometric sequence we were dealing with earlier. First we're going to make a table. Okay. Again, the term number is 1, 2, 3, 4. Unless they tell you that this is the 7th through the 12th term, you're going to start with 1 through 4. And then write down the value of the term here. Okay. Now, this may take a little bit of determining on your part. Okay. So remember we made that graph out of this, or you know that the constant ratio was 27 divided by 9 equals 3, and 9 divided by 3 equals 3. So our constant ratio is 3. Okay, so what do I do with that 3 so that I get 27? And it's not adding or subtracting. It's not even multiplying, because that's an arithmetic sequence. Well, these are ratios of 3. So I'm taking, I'm multiplying, I'm taking 3 times 3, and then I'm taking 3 times 3 again, times 3. So I'm doing something with exponents here. So you might think that that the rule is take 3 to the n power, right? It's going to be a base of 3 because that's what you have, and you're multiplying it repeatedly. So in words, well, we'll save the words until we figure out what the function is, okay? So if I use 3 to the n power, if I use using our subscript notation, a sub 1 equals 3 to the 1 power, that would be 3. And if I use a sub 2 equals 3 to the 2nd power, that's going to equal 9. And if I use a sub 3 equals 3 to the 3rd power, that would be 3 times 3 times 3, which would be 27. So this would be saying that the first term would be 3, and the second term would be 9, and the third term would be 27. And I look at my list and I realize I'm off. So look at the first term. How do I use 3 to some power to get 1? Well, that first term needs to be 3 to the 0 power. So I need to take a 1 and subtract a 1 from it, right? And this one, okay, so if that bumps that up, and this is now, we're going to cross these out because we're going to put these in the right order. This is 1, this should be 3, this should be 9. If this is 3, this needs to be minus 1 power. And this needs to be 3 to the 3 minus 1, because that would be 3 squared, and this would be 3 to the 1st, and this would be 3 to the 0. So it is the position number, but I have to subtract 1 from it every time. So here's your rule. It is a sub n, remember that's just the position number, equals 3 to the position number minus 1. I always have to subtract 1 from it so that I get that starting position of 1. Now that's for this formula, or for this sequence. If I started with a 3 in a sequence, then maybe just 3 to the n power works, right? So you're going to have to double check your rules to make sure they work. So if I were to use this to write this sequence out in words, I would say we are going to take 3 to the power of the position number minus 1. Okay, that is in words. To find the value, take 3 to the power of the position number minus 1. Alright, so again, this is just a subscript. So if I wanted to find the value of the 8th term, I would use the subscript 8. So a sub 8 equals 3 to the 8 minus 1 power, which would be a sub 8 equals 3 to the 7th power. And then I would plug that into my calculator and get the value. Okay, so a lot of new terminology maybe for you. Make sure you're asking questions and verifying that you understand what we're talking about, especially with this subscript and with the rules to determine whether you have arithmetic or geometric sequences. Okay, and with that, I will see you in class.